Have you ever wondered how you could use multiple JSON Web Tokens inside of the same .NET application? These would be tokens created by different issuers, and we want our .NET application to be able to authenticate these tokens. Hey, my name is Milan, I'm a software architect and Microsoft MVP, and in this video I will walk you through the use cases for having multiple JSON Web Tokens and how to implement this inside of an ASP.NET Core application. Let's begin by explaining how using multiple JSON Web Tokens would work in practice. We have our application server on the one end and a client application on the other, and we want our client application to be able to send requests to our web server, and we also want this to be authenticated. So we decide to use JSON Web Tokens. And for example, a JSON Web Token could be issued by Keycloak, which is an external identity provider that I've covered in some previous videos. But let's also say we have a different client application that also needs to authenticate with our web server using JSON Web Tokens. But an additional requirement is that this JSON Web Token is issued by Supabase, and our web application must be able to authenticate both of these JSON Web Tokens. Now, what are the use cases for something like this? For example, we could have different client applications that need to integrate with the same web application. And it's quite possible that these client applications will use different authentication providers to acquire these access tokens. Another example could be using one type of JSON Web Token for common API requests, and then when we need to do some sensitive operations, we could elevate our access level by acquiring a JSON Web Token that grants us additional privileges that would allow us to execute these operations by calling the respective endpoints on our web API. So whatever the reason is, in the end, we need to support authenticating with multiple JSON Web Tokens inside of an ASP.NET Core application. And this is in fact possible, and I'm going to show you how to implement this right away. And I'm going to start by showing you how to integrate one identity provider. In this case, it's going to be Keycloak. And then we're going to introduce our second identity provider, and I'll show you how to add support for authenticating both of these JSON Web Tokens. So what we have right now is a more or less plain .NET 8 application with one protected endpoint that is just going to return a dictionary of the claims present on the current claims principal. Now, in order to run Keycloak, I added it inside of my Docker Compose setup. So here is the setup for the Keycloak container. I'm using the latest version of the Keycloak image. I'm setting some environment variables, adding a volume, and I'm exposing Keycloak on this port on my local machine. So when I start the application and I open up Docker Desktop, you will see that I have my three services running: my .NET API instance, the Keycloak instance, and Jaeger for distributed tracing, which we won't focus on in this video. So I want to focus on Keycloak, and if I navigate to this port, I will be greeted with the Keycloak UI, where I can specify the admin username and password. And this will open up the master realm of Keycloak. You can consider a realm as a collection for your application's users. And I already created a realm that we are going to use in our example. It's called Keycloak Auth Demo. And inside of this realm, I registered one user with some dummy email and password. But I also have a client called the public client, and a client represents an application that should be able to authenticate with Keycloak on behalf of a user. So I'm going to use this public client to get an access token for my user. I also configured this client to support the password authentication flow, and this allows me to send a post request to the Keycloak instance running on this port. I have to specify the specific realm that I want to send this request to, and then this is a well-known route for getting an access token. I also have to specify some additional arguments in the request form, and I have to say that the grant type is password. I'm specifying the name of my client, which is public client, and I'm specifying the username and password of my user. And when I send this request, I will get a response back that contains an access token that is valid for some period of time. You can decode this token on JWT.io and see what's inside. Now, the next step is going to be adding support for validating this JSON Web Token from our .NET API. So now we're back inside of our .NET application, and we're going to need a NuGet package that's going to allow us to authenticate with JSON Web Tokens. And a well-known library for this is Microsoft ASP.NET Core Authentication JWT Bearer. So this is the library that I will have to install, and then I can set up some required services for authentication. So I'm going to say builder services at authentication, and I can specify my default authentication scheme, and I'm going to say JWT bearer defaults and use the authentication scheme constant where the value is bearer. And then I can say add JWT bearer, and this will allow me to add authentication for my JSON Web Token. So I'm going to provide a delegate to configure the JWT bearer options. And all we have to do is just provide a couple of values for validating my JSON Web Token. And what these values are will depend on my identity provider. In case of Keycloak, I have to provide a couple of values, and these values are the metadata address, the valid issuer, and the audience, which has a fixed value of account. The authorization URL is optional. I'm using it to add support for authenticating with Keycloak from the Swagger UI, but if you're interested in this, then you will also need the authorization URL. And you will notice that this follows a very similar format. We are specifying the URI where Keycloak is available and then the name of our realm. So I'm going to paste the Keycloak auth demo realm in all of these arguments. And then the other values here are all well-known routes with OAuth. So we have our auth endpoint. We have the endpoint for fetching the OpenID configuration. The valid issuer is going to be our Keycloak realm. And then we know the value for the account. And now I just have to configure these values with my JWT bearer options. So I'm going to say options require HTTPS metadata, and let's set this to false. Then I'm going to say options audience, and this will be builder configuration. And then I'm going to specify my configuration value. So authentication, Keycloak, and then I will specify audience. And then I'm going to do some copy pasting, and I want to set my metadata address to the respective value that will come from this configuration option. And I'm going to use a null forgiving operator to make this simple. And then I need to update the token validation parameters by instantiating a new instance. And here I want to set the valid issuer property to the value coming from my configuration. Then I'm going to add the authorization services by saying builder services add authorization, and we also have to include the authentication and authorization middleware. So I will say app use authentication and then app use authorization in this specific order. And now let's start the application and see if we can authenticate against this endpoint. So with my application running in the background, I'm going to take the value of this access token, and then let's navigate to the endpoint that I want to call. It's available on this address, and if I send a request without an authorization header, we're going to get back a 401 unauthorized response. But if I specify the bearer token as my authentication type, and I paste in my access token value and send this request, you will see that we do indeed get back a valid response, so we are able to successfully authenticate with our application using Keycloak. But now let's make this example a bit more complicated by introducing another source for acquiring access tokens. I'm going to use Supabase, which is a popular platform for building applications, and it comes with many services out of the box, like a Postgres database, authentication. You can also access cloud storage and real-time capabilities, but I only want to focus on authentication. So you can navigate to the authentication section where you are able to create a user for your Supabase project, and you can do that by clicking add user. You can see I already have a user from before, and I will use this user to authenticate with Supabase and obtain an access token. And then we're going to implement validation for this access token inside of our .NET application. Now, in order to achieve this, we will need to grab some configuration values from Supabase, and you can go to the project settings, and from the project settings head over to API. Now from the API settings we need two values: the public API key, which is this value here. You can copy it directly from the UI, and we're going to need this to send a request to the token endpoint to get back an access token. The second value you will need is the JWT secret, which we are going to use to validate the access token. You can also reveal and copy this value from the user interface right here. So now that I grab these values, I can send a request to the token endpoint, which is available at this route. This is the unique name for your Supabase project, which you can copy from the Supabase dashboard. And then you will append supabase.co.auth v1 and then token. And I will specify the grant type as password. The arguments are going to be the email and the password in the request body. And I also need to specify the API key header where I'm going to pass the public API key value. So finally, when I send this request, I will get back an access token that I want to be able to send to my .NET application and authenticate on behalf of my Supabase user. So let's try sending this access token and see what's going to happen. So I'm going to specify the token value here and send this request, and you can see that we get back a 401 unauthorized response. So right now we aren't able to authenticate using an access token issued by Supabase. But let me show you what you need to do to change this. I'm going to add a new value inside of my app settings JSON, and this will contain some Supabase configuration that I will use to implement authentication. The issuer this time is my Supabase project and the route of the authentication service. The valid audience is authenticated, and then we have our JSON Web Token secret that I grabbed from the Supabase UI. So now if I go back to my program file, all I have to do is add another call to add JWT bearer. However, if I don't specify an authentication scheme, we're going to run into a conflict. So I'm going to add a small helper class that's going to contain my custom authentication schemes. I'm going to call this the custom auth schemes, and I'm going to make this an internal and static class with some internal constant string values. And one authentication scheme is going to be Keycloak that we already have. And then my second authentication scheme is going to be Supabase. So I'm going to add a respective constant for that. And then we're going to use this inside of our program file. So here I want to specify custom auth schemes and then Keycloak. And I'm doing this so that I can differentiate this from the Supabase custom auth scheme. And we also have to configure some values for authentication to work with our Supabase scheme. So I'm going to add the configuration that we need. We're going to grab the JSON Web Token secret and extract it into an array of bytes. And we're going to use this to set the issuer signing key in the token validation parameters. And I'm also going to specify a valid audience and a valid issuer. So this is enough to set up authentication with Supabase. However, if I just try to authenticate using the default authentication scheme, or rather the default authorization policy, we're going to run into a problem. So we're going to solve this by simply overriding the default authorization policy. And you can do this by configuring the authorization options when you call add authorization. So what do I want to do here? I want to create a new instance of the authorization policy type, and I'm going to call this my default policy. And how you create this is by creating an authorization policy builder, and the arguments for this type are going to be your authentication schemes, and we have two of them. One is the Keycloak scheme, but we also have our Supabase authentication scheme. Now I want to customize my default policy, which is that I simply want to require the current user to be authenticated. So I'm going to call require authenticated user, and then let's just build our authorization policy. And now I want to update my authorization options to set a new default policy that's going to apply to both the Keycloak and the Supabase scheme. And this will allow me to just continue using require authorization without having to specify which scheme I'm using. An alternative to this is using the authorize attribute if you want to use attributes to decorate your request delegates, or you are using controllers. So let's start the application now, and I'm going to send a request to this endpoint using the Keycloak access token, and you can see that we are getting the value back, and we can confirm that this is coming from Keycloak based on the issuer. Now I'm going to grab the Supabase access token, which I have here, and let's paste it in, and I send this request, and you can see that we get a response back. And we can also confirm that this is coming from Supabase based on the issuer. So you can see that now I'm able to authenticate inside of my application from JSON Web Tokens coming from two different issuers. Now, wouldn't it be useful to be able to specifically know which identity provider the current user is using to authenticate with our system? So one way to solve this is to introduce a custom claim that's going to represent the current authentication scheme. And you can do this by introducing a custom claims transformation. And let me show you how we can achieve this. I'm going to add a new class called multi-JWT claims transformation. And this class has to implement the iClaims transformation interface. And all this does is exposes one method that gives us access to the claims principal and allows us to modify it. So I'm going to inject the iConfiguration interface to be able to access the issuer configuration in my application settings. And let's add a name for the custom claim that I want to use, which is going to be called the authentication source. So I'm going to call this auth source. And one thing to remember when implementing this method is that the transform async method should be idempotent because it can be called more than once. You can solve this by checking if the claims principal already has this claim. So you can check that the claim type is equal to auth source, and if it has this claim, then we can just return task from result and let's return the current claims principal. Otherwise, I'm going to create a new instance of a claims identity, and I'm going to grab the issuer from the current claims principal instance. I'm going to do that by looking for the issuer claim in the claims that are currently present. And then I want to compare the issuer to the valid issuer inside of my configuration for Keycloak, for example. And in that case, I want to update my claims identity by adding a new claim. And let's create a new claim with this claim name, auth source, and the value is going to come from our custom authentication schemes, and let's specify Keycloak. Otherwise, I want to check if the issuer is equal to the Supabase valid issuer. So let me update this. And in that case, we're going to add a new claim that says that the auth source is Supabase. And then we're going to update the claims principal by adding a new claim identity. We have to call the add identity method, and I can pass in my claims identity instance. And then I'm just going to return task from result and return my updated claims principal. I also have to register this as a service. So I'm going to say builder services add transient, and I'm going to specify the iClaims transformation interface and my custom implementation. And now when I start the application and the application is up and running in the background and I send an authenticated request to my API, we're going to land on this breakpoint in my claims transformation. And you can see that the first check passes because I don't have an auth source claim. So I'm going to check if this is one of the available issuers. In this case, it's going to be Supabase. So we're going to add a custom claim and I can press continue. And inside of Postman, we can see that we have another claim present where the auth source is Supabase. Now let me grab another access token here for Keycloak and send this same request again. And this time we should see that the auth source is Keycloak. So now I can easily distinguish between the different authentication types that I'm supporting on my backend. So this is how you can add support for authenticating using different JSON Web Tokens from different issuers inside of the same ASP.NET Core application. And if you enjoyed this video, make sure to smash the like button right below. And if you want to learn how to extend this with robust authorization support using roles and permissions, then you should watch this set of videos next. I hope you got value from this video. Don't forget to smash the like button right below, and until next time, stay awesome.